When you measure most batteries with a battery tester, you're actually drawing current. So it isn't precise enough for the exact EMF, and it doesn't tell you whether it will take a load. Something can read, let's say 12 volts is on a car battery, but it won't start a car. So if I put these on the terminals here, I'm reading 1.476 volts for the D cell. I'm reading 1.532 for the C cell. And I'm reading for the double A, ooh, this is a bad one. This would be 0.86. Double A's are supposed to be between 1.2 and 1.5. So undoubtedly, even this voltmeter says that's a bad cell. So I would remove this from the experiment and go find another one, preferably one that isn't rechargeable, because that'll defeat the purpose. So what we're going to do is test these 3 batteries with a device known as a potentiometer that we're going to build. And the idea of the potentiometer is that you're actually measuring the real EMF under load conditions, which is what the technician does when he checks your car battery to see if in fact it will start your car. Because you could charge it overnight and it still wouldn't turn over, even though it says the battery's full. If the battery is weak, and it'll rapidly discharge, and you could see the voltage drops very, very quickly. So, how do I do that? How do I set up the potentiometer? Well, the first thing I need to do is to make sure I've got the right amount of voltage across the slide wire, and I do that by setting it up so that I can drop current across it until I reach about 2 volts. That will give me an electric field of 0.02 volts per centimeter. So if you look over here, this is reading 1.19 volts, so that's much too low. So I want to reduce the resistance until I get this exactly up to 2 volts, or close to it. I've got it 1.9. I've got it exactly at 2 volts here. Then I would test it here at the 100 mark, and it says you got a ways to go. Okay, I've got 2 volts. Now I would test it to see if it's consistent. I would test it at 90 to see if it's 1.8. I would test it at 80 to see if it's 1.6 or close, and this reads 1.61. I would test it at 70, then I would test it at 60, 50, 40, 30, 20, 10, and finally 0. That will give me essentially a y is equal to mx plus b relationship here. Okay, once I've done that, I need to put a circuit in place that you've seen on your diagram in the lab manual, where I take the positive side of these batteries and I hook it to the positive side of the circuit here that I've just calibrated. When both sides read the same voltage, I'm measuring the actual EMF. So I essentially go from the negative side of here. Then come over to here, and then I need to touch. Now, if you take a look at this dial, and I touch it here at 60, it deflects one way. If I touch it 90, it deflects the other. So when I exactly balance what the voltage is over here, I've got my true EMF, or so the story goes. So I'm about 70, and you see it rapidly coming up to 0, and I'm reading this at 72.3. 72.3 times 0.02 would give me something on the order of 1.44 volts. Very easy to do, plus or minus whatever number I got over here after I do a slope and intercept equation using a handheld calculator or a spreadsheet. So if I test battery D cell, then I test the C cell, then the AA. Then I put my multimeter across, let's say, the D cell and read it while I'm tapping. If your multimeter has a bad internal resistance, you'll get a very, very different reading. If the battery is bad, you'll get a very, very different reading between the potentiometer and the multimeter reading. Then finally, what they used to use in the olden days is something called a Weston cell. And as you notice, this is a black case, it's an electrolyte, and it was guaranteed to 5 significant figures. But in pressed on print, it says never put on a voltmeter. Well, how can you read pressed on print if you're in a classroom? And no one told you to be careful with that. So chances are this $80 Weston cell may or may not be bad, which is why we're also looking at the direct wire. I put this in place, it should balance at 50, and then in theory, I should have a standard measurement and a standard voltage to compare my other numbers with.